Hello denizens of YouTube, Mike here today with a quick little video to take you guys into the guts of a lightsaber once again to show you guys the difference between a single LED setup and a tri-LED setup. Now the reason why I'm making this video is because, to my knowledge, there isn't a video showing how a lightsaber can be wired in this particular fashion, so I wanted to make a quick little video to show you guys this in case you are interested in building lightsabers and using the same method that I use when I wire my lightsabers. So I'm gonna move the camera down here so you can see this. So if you've seen my previous video where I explained the insides of the Sentinel Mark II, you notice that this is pretty similar. In fact, the only really major difference in this setup is the LED itself. So if you can look here, get this right in the camera, hopefully you can see that really well. You can see that there are 3 LEDs and 6 pads in total. There's a positive and a negative for each LED. Now, there are 2 different ways that you can wire a tri-star LED. You can wire it in series, where, if I understand it correctly, you only have 1 positive and 1 negative wire, and then you are going to hit those little itty-bitty circles in between the LEDs with solder and basically bridge the gap so that all 3 LEDs will wire in series. So the current will go in, it'll hit one LED, travel to the other LED, travel to the third LED, and then come back down. But what I have done is I have wired all of my LEDs in parallel. So each LED is its own individual circuit. They each have their own positive and negative wire. So when the current flows through the wire, a third of it's going to go into one LED, a third of it's going to go into a second LED, and the remaining third is going to go into the third LED. And for a full disclaimer, I'm not an electrical engineer. I have very little knowledge about the electronics. This is just what I have gleaned off of the internet and the forums and looking at Ohm's law and trying to make sense of it. So yeah, that's the really the only major difference between the tri and the single LEDs, at least for me, is just I do the same thing times 3. And the reason why I do that is because if you have each LED running as its own circuit, the amount of voltage does not add up. If I remember correctly from when I was talking to a representative at Luxeon, if I were to run all of these LEDs in series, the appropriate voltage for maintaining all 3 LEDs would be higher than what I could manage to fit into a hilt. It would basically look like a proto saber. I would basically have the hilt, and then I'd have a battery, like a massive battery on my belt right here to be able to power the whole thing. So by having them each as their own individual circuit, they all maintain their original quality, which is that 2 lithium-ion batteries in series will be able to adequately power them. And also the current is split evenly amongst the 3, which is what I'll be getting into the next part of the circuit. But for now, you just have the starboard here, and you have this on this little copper heatsink, and then you have your tri-lens, and you just line it up in the holes right here, and then you take your housing unit and screw this on. There, nice and tight. Wipe off the lens. And there you go. Now you have your LED module. You got your positives and your negatives right here. Eventually what I'm going to be doing is I'm going to solder all of these to a single wire, so there's a single wire for the positives and a single wire for the negatives, but we'll leave that for another time. And then you have the rest of your circuit, which is just like a single circuit. You've got your 2 3.7 volt, I believe 24 milliamps lithium-ion batteries wired in series for a total of 7.2 volts, and then you have your latching switch that will serve as the circuit breaker or allower, and then you have your current regulating device here, and you'll notice that it's a different shape from the current regulator that I used in the single, and that is because this is a 2100 milliamp buck block as opposed to a little buck puck. So these are what Luxeon makes for die and tri rebel circuits, because you can get a 1400, which would be great for 2 LEDs, or a 2100, which is used for 3 LEDs. And what that will do is you get the power from the batteries turns into a current of 2100 milliamps from this buck block, and then it goes up to these leads right here, and that will then split ideally into 3 equal currents of 700 milliamps, which is the recommended current for pretty much all of these LEDs. So that, I guess the only thing that's left is to show you guys, and I actually need to unscrew this again because I need to make sure which is positive and which is negative. So let's see here. Positive, okay. So positive is right here. And what I'm going to be doing, what I will do eventually also, is I like to put colored tape, colored electrical tape on the wires to give them a color coding, so I know without having to do this over and over again which is positive and which is negative. Usually do white for the positive and blue for the negative because it matches with the buck block. Okay. So make sure all of these are connected. My wires here are good. I'll press this switch now so there's nothing impeding the circuit, and I'll just connect. And there you go. You now have a complete circuit with your tri-LED. So that's that. That is basically the internals of the lightsaber with a tri-LED setup, just the way that I run it. And I based this setup off of what I got from the Luxeon representative. I talked to them and I said, listen, this is what I want to do. This is what I want to run. What do you recommend, since these are your products, to ensure, maximum brightness and the longest lasting life of your products? And they said, well, we recommend that you do this. So that's what I'm doing. That's basically, just following their rules. The one thing I would like to point out, though, is a buck block that you use for a single LED will be able to fit inside a 1-inch PVC pipe, whereas the buck block that you would use for die and tri setups, I actually have a piece right here of 1-inch PVC, and here's the buck block. Not fitting. There's no fitting whatsoever. So what I did with Suyoi Heibi, and what I'm also going to be doing with other lightsabers that do a die or tri setup, is I actually will be carving a window. Let's see if I can get in here. Carve a window here, and then carve a window on the exact opposite side. And what I'll essentially be doing is I'll slide the buck block in, and then it'll fit perfectly. And then that can fit perfectly inside of a 1 1/4 inch diameter. But I'm okay with that. It's not too hard to do, and it actually guarantees that the buck block doesn't move around. It will remain stable inside the hilt when I'm battling and shaking it around. So I'm okay with it. Hey, it's a win-win. I just can't, I can't have an inch diameter hilt in that particular section. It'll have to be covered up by 1 1/4 inch if I want it to be completely protected, which I do. So, yeah, that's it. Actually, you should be expecting videos coming out in the next 2 months, because this circuit here is actually for a commission that I'm working on, and there's also another commission that I'm working on, both of which are going to be done by the holidays. So yeah, hopefully you guys should see a video reveal for those in the next couple months. But until then, take care, and may the Force be with you, always.